Mangrove forests are among the most carbon-rich ecosystems on the planet. To understand how much carbon they store and how they respond to change, we measure greenhouse gas fluxes directly from the soil. In this video, we guide you step-by-step through pre-fieldwork preparation, fieldwork measurements, post-fieldwork care, and data processing using the LI 7810 gas analyzer and the 8200-01S smart chamber. The full workflow has 4 stages. First, pre-fieldwork preparation in the lab. Second, fieldwork, installing the rings and operating the gas analyzer and the smart chamber. Third, post-fieldwork cleaning and storage. And finally, data processing and quality control. Before going to the field, take time to familiarize yourself with the gas analyzer and the smart chamber. Identify each button and learn its function. Review all gas and data ports and check that the tubing is correctly connected. Always keep connector ports clean and covered when not in use to prevent dust, moisture, or salt contamination. Use a checklist to prepare your gear. Verify that the gas analyzer and the smart chamber are functioning, the silica gel is active, and all the batteries are charged. Pack essential fieldwork tools. Please use the checklist provided in the mail as reference. Always carry the printed permits for site access. So these are the basics for measuring CO2 and methane in the field. So first you need to check that you have the smart chamber, the cable that connects both instruments, the analyzer, and the batteries. So first we plug the batteries to the equipment. So the smart chamber uses only one. So we need to be careful that the pins that are inside the chamber kind of fits with the battery. And then we connect the batteries to the light car, but before that we have to be careful of removing first the blue caps of the air inlet and outlet ports. So we double check that the pin fits in its place. And then the instrument immediately turns on when it's receiving power. After you install the batteries, you have to connect the instruments using this cable. So first recognize the port in each instrument. The smart chamber have the quick connectors and the gas analyzer have the screw. The end of each cable, you will see them, and each of it have the black tape that helps you to recognize which one is the outlet cable. So in the smart chamber, you just plug very easy with the compatibility of the quick connectors, and you will see immediately here says out, and the cable, the black cable, fits in properly. And then we connect them using an Ethernet cable. And then same with the gas analyzer. Locate first where is the out, and then connect the cable with the black tape. And same with the inlet. Finally, put the Ethernet connection, and then it's ready to turn the instrument, the gas analyzer, on. So in this side, you will find the power button. Just press it once. The smart chamber, it's already on, so it doesn't need to warm up, but you need to leave the gas analyzer warm up around 30 minutes. So after you finish setting up the instrument, then you can start to connect them using the Wi-Fi networks. So first you connect the computer or your mobile phone with the smart chamber using the information described in the label. And to connect with the gas analyzer, you use the information described in the display. Connecting to the gas analyzer. Locate the Wi-Fi network on your mobile device. The network will be named with the device serial number. To confirm the serial number, check the upper left corner of the display screen or refer to the sticker located beneath the case. The default password for the network is like or envy. To visualize the data, use the web browser and access the analyzer by entering the host name or using the fixed IP address. For your smart chamber, check the info specified in the label next to the power button. As with the gas analyzer, search for the local Wi-Fi network broadcast by the smart chamber. The network name will be 82S and the 4 digits of the serial number. Use the same password and connect. Then, in your browser again, enter the host name or use the fixed IP address. After connecting to the Wi-Fi, ensure both devices can recognize each other using the Smart Chamber network. On the main screen, select the option icon to access settings, where the essential fields for operation can be managed. First, select the analyzer, which must be the one with your serial number, and click in Update, so they will be linked. After that, the software automatically syncs necessary information, such as total volume and clock settings for correct operation. Before starting any work, check date and time in both devices. First, navigate in the Analyzer platform. Look the upper right corner and select Settings, then open the time window. Confirm that the instrument time is set to auto-sync with the Smart Chamber server by entering the instrument's local network name and click Update. In the time zone window, make sure the country corresponding to your location is selected and click Update again. In the Smart Chamber, you can verify the time zone by clicking the Setting button. Then, in the software cell, look for your time zone and then update. More detailed work settings are typically managed through the Smart Chamber network. Organize the data into independent files, for example by campaign date or sampling site. In the Options menu, the first window, labeled as Files, opens the Data Output section. Here, the cell New Output File sets the file name, and New Output File remark allows you to add additional or relevant comments. Then, click on Update and confirm to create the new file. For more options of file names, please check the examples in the manual. In the field, first select suitable locations for ring installation. Once you find a stable place for setting the rings in the soil, you have to make some pressure to put it into the soil, and don't forget to leave it a couple of hours so the fluxes come back to normal, since when you are doing some mechanical movements of the soil, the regular emissions are interrupted. So please leave it a couple of hours and then you can start the measurements. Place the PVC rings where you will measure soil gas flux. Inspect tubbing and cable entry points on both devices. Connect the gas tubbing to the gas analyzer, air inlet and outlet ports, and attach the communication cable. At the Smart Chamber, connect the quick connects for air tubing and the data cable, keeping inlet and outlet orientations consistent. Before starting the measurement, with a ruler in centimeters, take 4 points of the color and make the promedio the average of the offset. From the Smart Chamber network, navigate to Options, select Configuration and enter the color offset in the Constant window. In the Volumes window, select Set Volumes to open the Volume Setting window. Here, verify your analyzer tubing setting, the hose that transport gas between the analyzer and the chamber. Choose the appropriate tubing length, which will automatically update the other volume calculations. Then, verify the smart chamber volume by clicking Autofill and click Set. After that, you will see all the volumes adjusted. The final window, Configuration, allows you to adjust parameters such as the length of each observation, the deadband, which are the seconds after the chamber closes, allowing thorough mixing of soil gases for stabilization, number of repetitions, which automatically continues with subsequent measurements if there is more than one, and the post-purge time, seconds when the internal circulation pumps continues running after measurements to clean the chamber internal area. The upper right corner contains a remark cell where you can enter the measurement label. Press Start Remark to begin measuring gases for a specified period. Once the time has elapsed, press End Remark to ensure that no additional data is included in that particular remark section. On the main screen, the green Start icon opens the configuration window for each measurement. Here you can adjust the offset between rings, assign an ID tag to distinguish the name of each measurement, and also include an ID remark to provide more information about the measured point. For more ideas of how to name your measurements, please check the example included in the technical manual. The smart chamber only shows data captured by its camera, while the analyzer offers specific data for the gases of interest, such as real-time concentrations or fluxes. Select the variable to be graphed by clicking in the empty area adjacent to or below the graph display box. After selecting the desired data, click the variable again to generate its graph. In the main screen of the gas analyzer, you can see real-time measurements of carbon dioxide, water vapor, and methane. When connecting to the laptop, you will see the three graphs in real time as well. If you are using a phone, just click in the gas and you will see the graphs. In order to export data from the gas analyzer, locate the option icon and select Export to download. Select the specific dates from which you want the data to be exported. Since the analyzer continuously collects data after completing its warm-up cycle, you must specify the desired data and the time range to include in the exported package. After that, your data will be named with the gas analyzer identifier and the date. When exporting data in the Smart Chamber, within the Options menu, select Files to view a list of files groups saved in the device internal memory. In the Action column, choose the second option to download a file in a JSON format. This file should be then uploaded into the Lycor data processing software for analysis. After installing the software, start it and select the Open window in the upper left corner. Choose the file you wish to work with, and the field measurements will load immediately. Use the Displayed option in the upper right corner to add or remove columns or information as needed. At minimum, open the carbon dioxide and methane fluxes and its R-square tabs to evaluate the quality of each measurement. Double-click on a measurement to reveal a window on the right, containing detailed information provided by the analyzer. such as measurement specifics, linear flux regressions, and options for data editing. You can remove points from the graph that do not correspond to the valid measurement times to improve the quality of the final flux. Additionally, if you make mistakes during fieldwork, corrections can be made by pressing Recompute and Metadata. In the chamber options, for example, you can adjust the offset, or in the Analyzer section, adjust the topping volume. After completing the quality control, use the export feature to generate a CSV file, including the columns you have selected in the display. This data is then ready for further statistical analysis. By carefully preparing your equipment, following a consistent field protocol, protecting your instrument, and applying rigorous data processing, you can produce high-quality soil greenhouse gas flux measurements in mangrove ecosystems. These measurements support more accurate carbon accounting and ultimately better decisions for mangrove conservation and restoration. For detailed written protocols and additional guidance, refer to the accompanying manual and projected documentation.